Welcome to our senior secondary physics series. In this video, we're going to take a look at a subtopic of the topic measurements entitled prefixes. Let's get started. So in measurements, units can be stated in terms of prefixes. What are prefixes? A prefix is a word added before a unit. The reason we add prefixes is to avoid using many digits to represent a value. So I'll give an example of meters and kilometers. So meter is our basic unit, one of the SI units. What about kilometer? So kilometer is made of two words. The first is kilo, the second is meter. The kilo is the prefix and meter is the normal SI unit. So what does it mean when we say kilometer? What's the difference from meter? How does kilo changes the meaning of meter? So let's say we measure something and it's 2000 meters. So in physics, measurements that are represented by two main digits need to be avoided. So instead of writing 2000 meters, we can write this in a shorter version. So kilo, what kilo means? Kilo means 1000. So instead of writing 2000 meters, we can just write 2 kilometer, since kilo means 1000. So when you say 2 kilometer, it means 2000 meters. So that's what prefixes are, and that's what they do. So you can see that 2 kilometer has one digit as compared to 2000 meters, which has 3 digits. So it's a common practice in physics when we are solving, when we are making measurements, to represent a given measurement with a small number of digits. So that would require you using a prefix. So we're going to use this table to understand prefixes. So in this column here, I've got types of prefixes, actually different prefixes that we use in physics. There are many, but these are the ones that we're going to be dealing with the most. Then the second column here, entitled symbol, we've got the symbols that represent the prefix. So for example, the one that we have looked at, kilo, instead of writing the word kilo in front of, actually before meter, the word meter, we just write K. So instead of writing kilo, meter, just write km. And someone who understands physics should be able to tell that km stands for kilometer. Then the third column, we've got value. So what value means is the number that prefix represents. So for kilo, the number is 1000, just like from the previous example, I said kilo means 1000. So that's how it is. Then the last column is just another way in which to represent the number. Those who have studied indices will understand. Those who haven't, it's okay. I can explain. So 1000, how to remember that K represents 1000, you can just remember 10 power 3. So 10 power 3, what it means is you multiply 10 by itself 3 times. So it will be 10 times 10 times 10, which will give you 1000. Or you can just remember as 10 power 3, it's 1 having 3 zeros. The 3 on top here just should give you an idea of how many zeros should be before or after 1. So if it's a positive number, then it's before 1, but if it's a negative number, then it's after 1. Like if it's a positive number, then it's after 1. I think this side you can call it after 1, but if it's a negative number, then it's before 1. So for example, this is 10 power negative 2. That means that's got 2 zeros on the left hand side, or before 1, which are these zeros here. So this is how to recall the prefixes. Let's just go through them. So this is nano, represented by small letter n, and it has got 9 zeros. This one is easier to remember. Nano, it's like, sounds like 9, so you can use that. So it has got 9 zeros. If you count here, there are supposed to be 9 here, or you can say 10 to the power negative 9. So we're going to see how to use this in the next few seconds or minutes. Then micro is represented by this Greek letter here called mu. That's the name of this letter. Yeah, so it means 6 zeros before one. Milli, it's M, like millimeter, just like that. So it's 3 zeros before one. Centi, it's C, and 2 zeros before one. Centimeter, kilo, it's K, like we have studied, with 3 zeros after one. Then mega, it's M with 6 zeros after one. Giga is G with about 9 zeros after one. So these are the prefixes. Your job is to master these. With time, you get to know what nano is, micro, but for now, try as much as possible to acquaint yourself with these. Nano should remind you of 9 zeros before one, micro 6 zeros before one, milli 3 zeros before one, centi 2 zeros before one, kilo 3 zeros after one, mega 6 zeros after one, and giga 9 zeros after one, and also the symbols. So we're going to learn how to use prefixes through an example. So the question says convert 25 kilometers to meters. So this question is direct, it requires us to convert, but normally it might happen that they have given us a question or a measurement to carry. After carrying that measurement, you get your answer in kilometers, but they want it in meters, so you have to convert. Anyway, let's learn how to convert. So what we do is you write like this, kilometer to meter. So you have got the left hand side, which is the region or the area or the part you're going to be writing things that are related to kilometers. Then on the right hand side, we have got the side for meters. After you write this, the next is you recall what you learned from the table. So you say kilometer means 1,000 meters. So say 1 kilometer, then the other side it should be 1,000 meters. So this is the part where the information you acquired in that table should be used. If it was from nanometers to meters, you could have said 1 nanometer to 0.000, that is 901 at the end, meters. So that's how to apply it. So 1 kilometer is equal to 1,000 meters. What's next? After that, you go to what you have been given. What have you been given? 25 kilometers. They want it in meters. So this 25 kilometers, you write it on the side of kilometers. Then on the side of meters, you put X. X means we don't know. We don't know what the meter value that is equal to 25 kilometers is. So put X. Once we put X, we do a mathematical operation that is called cross multiplying, like this. So what you do is you multiply 1 kilometer with X and 25 kilometers with 1,000. So they cross. So 1 kilometer times X, just like 1 times X. 1 times X is X. 1 times n number is that number. 1 times 1 million is 1 million. 1 times 500,000 is 500,000. So 1 times X is going to give us X, and 25 times 1,000 is going to be 25,000. So that's our answer. So it means 25 kilometers in meters, just 25,000 meters. That's how it works. That's the magic. Once you do cross multiply, what you're going to get in this case should be your answer, but not always. There's the next example where it's not always, where you have to do further mathematical operations for you to get the answer. Why are we satisfied that this is the answer? Because X means we don't know the value that it represents. But if you read this, it says X is equal to 25,000 meters, which means that which we don't know is equal to 25,000 meters, and this is the answer. You see the difference in the next example. So the last example says convert 25 meters to kilometers. So how do we convert 25 meters to kilometers? So the first thing first, we write our scale here, which says kilometer to meter. The question says 25 meters to kilometer, which means meter to kilometer, but I've written kilometer to meter deliberately. Why? I just want to show you that it doesn't matter which one you have written first. It depends on which one you are comfortable with. What matters is all information that has kilometer must be written here and this other side must be populated with all the information that has got meter. So let's get started. So the second stage we call the table. We remember that kilo means 1,000, so 1 kilometer means 1,000 meters. After that, we go to the data that we've been given. So I've been given 25 meters, which means we have to put it here on the side of meters. Then on the side of kilometers, we're going to put x, since we don't know what should be here. The job is to find this x, the unknown. So we can write as x equal to 25. After this, we do cross multiplication. So we're going to say 1000 times x is 1000x. For those who haven't done algebra, any number multiplied by any letter, you just put them together. Like 2 times b is 2b, 2 times z is 2z. So 1000 times x is 1000x. And 1 times 25 is 25. So it's going to be like this, 1000x equals 25. The next, in the previous example, we were done when we reached here, but here, this mathematical expression says 1000 times x equals 25. 1000x equals 25, or 1000x, which we don't know, is equal to 25. The job is to make sure that x is alone here. So how do we make it independent or away from everything? What we do is we'll divide both sides by 1000. So we'll divide here by 1000 and here by 1000. If we divide by 1000 here, then this 1000 will go. That's why I've chosen 1000. If there was 8, you could have divided by 8, so that this 8, when divided by 8, it will give us 1. And 1 multiplied by anything, the answer is anything. 1 times 5 is 5. 1 times 1000 is 1000. 1 times x, it will be x. So that's the way to deal with the number in front of x. So we divide both sides by 1000. For those who don't understand why we divide both sides, it's because of the equal sign. What the equal sign means, it means what is on this side should balance with what is on this side. So if you divide here, you should also divide this side. So we divide by 1000, we divide by 1000. So 1000 divided by 1000 is going to be 1. 1 times x, it will just be x. 25 divided by 1000, it's for those who are good with arithmetic, you can divide here by 25. You can divide 25 here, divide 25 here, or you can say 1025. Whatever you can do, doesn't matter how you get the final answer. Others can use the calculator, yeah, but it's going to give you 0.025 as the answer. So converting 25 meters to kilometers, the kilometer value is 0.025 kilometers. So this is how to go about it. Doesn't matter if they have given you nanometers, micrometers, the job is here. If they have said 1 micrometer, you have to equate it to 1 micrometer equal to 0. About micro, it's 6 zeros. So 6 zeros and meter at the end. So that's how to use prefixes. With this knowledge, now you are ready to do the actual measurements in physics. This marks the end of this subtopic. Hope you like, subscribe, and share. If there is any part you did not get, just comment using the comment section. Otherwise, happy solving.